이번은 Unsupervised and Supervised PCA 2편의 두 번째 동영상을 올리겠습니다. Rank of the covariance matrix equal x hat x check transpose. 이거는 x check라는 거는 그 PCA subspace 그놈이 그 U의 그 row space인데 그걸로 프로젝션 시켰다가 이놈을 다시 U의 column space로 다시 보내는 거예요. We consider two cases for x check가 d by n인 경우에 두 가지 경우를 보는데 첫 번째와 두 번째. 첫 번째는 if the original dimensionality of data is greater than the number of data points, 즉 that is d가 n보다 같거나 큰 경우. In this case, rank x check transpose가 n보다 크거나 작고, therefore rank s is rank x check transpose. 요거는 rank x check transpose 중에 작은 놈보다 하나를 뺀 거야. 그러니까 n-1이 되죠. 그러니까 rank s는 n-1보다 같거나 작다. Note that the -1 is because the data are centered. 데이터를 센터로 모으기 위해서 자유도가 하나 없어지죠. It becomes 0 after centering, and then rank should be 0. If the original dimensionality of data is less than the number of data points, that is d가 n-보다 같거나 작다. The n-1 again is because of centering the data. In this case, rank x check equal rank x check transpose가 d보다 같거나 작다. Therefore, rank s is rank x check transpose는 minimum rank x check transpose 이놈 중에서 작은 놈이니까 d가 된다. rank s는 d보다 같거나 작다. So we either have rank s가 n-1보다 같거나 작거나 rank s가 d보다 같거나 작다. Truncating of U. Consider the following cases. If rank S equal D, we have P equal D. We have D non-zero eigenvalues of S. So that you got D by D. It means that the dimensionality of the PCA subspace is D equal to the dimensionality of the original space. Why does this happen? This is because rank S equal D means that the data are spread wide enough in all dimensions of the original space up to a possible rotation. See figure 3. figure 3에 보면 이렇게 있다가 B1, B2 그 비슷한 형태로 되는데 B1, B2로 되겠다가 B1, B2 이렇게 바뀌는 거죠. 이건 B1, B2 이래야 되고요. Therefore, the dimensionality of a PCA subspace is equal to the original dimensionality. However, PCA might merely rotate the coordinate axis. In this case, D by D 행렬의 경우 is a scalar orthogonal matrix, so that UU transpose는 UU inverse가 identity 돼요. And U transpose U가 inverse U가 identity because rank U and rank U transpose 이거 다 D로 가고 rank U transpose D이고 and rank U transpose U도 D다. If U is a rectangular orthogonal matrix, then U transpose U는 단지 orthogonal 셈인데 U의 U transpose는 identity가 아니다. 요거 못합니다. If U is a scalar orthogonal matrix, then U transpose U and U transpose identity. PC is also referred to as coordinate rotation. If S less than D and N or D for the, it means that we have enough data points, but the data points exist on a subspace do not fill the original space wide enough in every direction. In this case, U in R D by P 행렬 경우 is not a scalar and the rank U P는 D보다 작다. We have a P non-zero eigenvalues over S. Therefore, U transpose는 identity가 아니고 and 요거는 D by D 행렬, P by P 행렬은 U transpose U는 아니 because rank U가 P고 rank U transpose도 P인데 이건 D보다 작고 rank U transpose U도 P고 if rank S가 n-1보다 같거나 작고 또 D보다 작다. It means that we do not have enough data points to properly represent the original space. And the points have an intrinsic dimensionality. For example, we have two 개의 three-dimensional points n equal 2, d equals 3, d equals 3, which are one two-dimensional line. This is space. Note that we might have rank S equal D. Thus, the part 1 to truncate the matrix is to have U D by P. Truncation U means that we take a subset of best reading eigenvectors rather than the whole D eigenvectors with non-zero eigenvalues. In this case, again, we have UU transpose는 identity가 아니지만 U trans U는 identity. The intuition of truncating is this. The variance data might be noticeably smaller than another direction. In this case, we only keep the PCD top eigenvectors, PCA directions, and ignore the PCA directions with the smaller eigenvalues to have U D by P 행렬, matrix. Figure 4 illustrates the case for 2D는 한쪽으로만 도미넌트하니까 두 번째 거는 잘라내버린다. Figure 4, 2D example where the data is almost on a line and the second principal is very small and can be ignored. 이 principal line이고 이쪽은 ignore, 무시해버려요. Note that truncating can also be done when you are D by P, we to have U T by Q, where P is the number of non-zero eigenvectors of S. 그 Q는 또 P거든요. For all the above analysis, we conclude that as long as the columns of matrix U D by P are orthonormal, we always have U transpose U equal I, regardless of the value of P. In the orthogonal matrix not truncated, and this is a scalar matrix, we also have U transpose equal identity. reconstruction in linear projection은 세 번째 동영상 올리도록 하겠습니다. 감사합니다.